Okay, welcome back, class. So I'm going to work three examples. Example 4 has A and B, and then example 5, then I'm done. This is based on the vector formulation, okay, of moment about a point. So here we want to find the moment of a force F about the point O. The force F is given. If it's not given, you know what to do. We've done that in chapter. You'll be given some information to write it down. So the only thing we need to know is the moment arm, the arm of the moment R. So moment about O vectorially is given as R cross F. It's given as R cross F. So F is given, we don't know R. So we go to the problem. And what is R again? R is, listen, oh, R is the vector from the point that you are taking the moment, in this case O, to anywhere on the line of action appropriately for you. We can be more than one, you get the same answer. So if you look at O here, the only point that we can recognize on the line of action of the force is B. So we just go from O to B. So this R here is vector OB. Is vector OB. Very important. And vector OB from here is 3. And you are going the Z direction. So this is just 3K. This is just 3K. Of course, it has a unit. The unit is that. F is in pound. So therefore, moment about O is given us, and you just use the determinant to evaluate it, I, J, K, followed by your R. Your R is 0, 0, 3. Very easy to evaluate. And your F is, somebody can keep this one, minus 40, minus 20, sorry, followed by 40. I need a big space to write this. Followed by 50. And you're done. The next is to evaluate this determinant. If you can evaluate it, you're good to go. So let's evaluate the determinant. You cover this, you cover that. So you do 50 times that is 0. Minus, okay, 50, you cover this, you cover that. 50 times 0 is 0. So 40 times 3 is what? Is it 120? 40 times 3 is 120. But negative I. Okay, negative I. Let me put this one very nicely. Let me put this one nicely. I don't need a bracket. So it's bracket here, negative 120 I. And then you cover this. Remember, this is already negative, plus, negative, plus. So you cover this and you cover that. So you are looking at 50 times 0, 0. The minus, 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 minus. 3 times 20 is 60. So minus, but it's already minus. So that is 60. And then that is a J. Somebody can check this. If there's an error, let me know. I'll cross check. So you cover this and you cover that. 50 times this is 0. The minus, minus again. Then that's already that. So that's correct. Then you cover this and you cover this. This time there is 0. This is 0. So yeah, there's nothing here. And this will be in pound dot feet. Very, very important. Okay. And they didn't ask you for the magnitude. If you want to get magnitude, it's square root of, if you can also get the alpha, beta, gamma. So just a note. It's not part of the work here, but just a note. Note. You can also work the magnitude of M about O, which is square root of 120 square plus 60 square. Okay, and you get the answer in also pound dot feet. You can also find this is just a note. They didn't ask you, they can also find the alpha, beta, gamma for the direction using the direction cosine, or you can use the angles, the corresponding angles. So take note, you can always find that. The next example is actually a 2D problem, but I want to solve using 2D and also use vector to solve it. And I'll show you the connection between the two. I'll show you the connection between the two. But we don't need. I've worked one of this example for you already. But okay, let's do that because the time is going. Okay, so method 1. scalar. Look, it's a 2D, so that's one with scalar formulation. Look at it using scalar formulation. So moment or resultant moment about O, okay, it's not really a vector, is equal to. So you split this into two. One is coming this way, another one is going that way. The one that is coming this way is going to push this down, and this is going to push it. So both of them are pushing the same direction. So very important. You see, this is going to push it down, and this is also going to, so both of them are going the same direction. So let's resolve the forces. One of them is 100 times, of course, 4/5. Okay, so that is the 4/5 one is this one. So the distance, let me wrap this, clean this off. The distance for that from O is 2. Yeah, perpendicular distance is 2. And it's add 100 times the 3/5. The perpendicular distance is from here to here, and it's 5. And both of them is going the same direction. Let me quickly do this. I think we can easily use use our head here. 5 goes here 20. And 20 times, is it 20 times what? 20 times 4 times 2. That is 160. Straightforward. Add 5 goes here 20. So we now have 20 times 3 times 5. And that is 300. And this answer is equal to 460. And let's take the unit. It's newtons meters. And if you go back to the question very well, this is most important for me. It's in this direction. I want to show you that this symbol is linked to the K. That is, for example, if you take this as your X and this as your Y. So I want to solve this problem again using vector formulation. But please, I'm urging everybody that if the problem is 2D, do 2D, don't do 3D. But it's for me to show you the link between the symbol we're writing. Okay, so let me zoom out a bit so that we can see. So let me write on the side method 2 using vector formulation. Vector formulation. So vector formulation, you write the force as a vector. And let's take this as our X, this as our Y. So it's like what is coming out is your Z. What is coming out is Z. If that is the case, then we can write the force as, look at this very well. We can write the force as, the horizontal one was 100 times 4/5. And that is I. And then minus, because that is coming down, minus 100 times 3/5. And that is J. So if you do this very well, you're going to get, this cancel, that is 20. So 80 I. This cancel, that is 20. So that is 60 J. And this is in newtons. The R, let me explain this. The R is this distance from here all the way here. It's our R. This is our R. So the R is, watch this carefully. You go this way and up. So the R is 5I plus 2J. And this is in meters. So then you set up the moment about O. Okay? Vectorially now. It's your R cross F. That's why you don't need to waste time. You see, this is a little bit, it's a 2D problem. If you want to do vector, you work too much compared to this simple thing. And that's what I want you to do. But I wanted to show you the link between these two. And that's my interest here. I, J, K. For this is 520. And for this is 80 minus 60, 0. Let's evaluate this. Let's evaluate this. This is equal to What is carefully? You cover this, you cover this. So it's minus 600 times. Oh no, you cover this, not 600, 0. This time this is 0, this time this is 0. So this is 0I. We come to this side, that is a minus. You cover this, so this time is 0, 0. Have you seen the answer? All the answer is going to, because we are working your ij, the answer is going to be the k, because the turning is happening about the z axis. So this is 0j, and then you do this one, and you're going to get 60 minus 60 times 5, then minus 80 times 2, and that is what? Negative 460. I want to show you the link between these two. Negative 460 Newton's meters. This in vector form. So you've written vector. Oh, sorry, and this has a k here. This has a k here. Okay. So let me show you what is going on here. The same answer, but let me show you the link. Because you are rotating this way, okay, this is your I, and that is J. Okay. If you are going that way, then if you do your right hand rule, the right hand rule is going to go in this direction. So even though as you rotate this way, the sense is going to go this way. This is the sense. It's going to go that. So this thing you see here is linked to this value. This thing is linked to this answer. This thing is linked to this answer. And that's the way I want it to work. Okay. Let me quickly do the example 5 so that I can able to post the video. So example 5. I have two forces, F1, F2. Okay. I'll try and do method 1, but we're not going to do method 1 and then method 2. Method 1, we are looking for the resultant moment about any point O. They can ask you another point O. And this is summation in general because it's more than one force of the R cross F. You could use this. This is a general concept. Okay, you could use this. So you could identify, let me take this off. You could identify the R's of each one. Okay. Okay, you could identify the R. And of course, they have the same R. So you don't have to worry. The common R is R1 equal to your R2. And this is equal to, let's check. You are going from this all the way to this point. And you have to move in the X, Y, Z. So you come this way, that is 4. 4 in the positive X, so 4I. Then you go up, or you come this way. Okay, that is 5J. Then you go up. Okay, you go up. Let me see, 4 up is 3. 3K. And this is in feet. So you are done. So all that I need to do is that your movement, I will not do this fully. I'll let you do the evaluation about this. Equal to 2 determinants. You're going to set 2 determinants. Let me clean this off. You're going to set 2 determinants. I, J, K. I, J, K. You put the R here, the same R, so 4, 5, 3. 4, 5, 3. Let me zoom in a bit for you to see, or zoom out, sorry. You put the first one, okay? So here, take note, what I'm using here is that I'm using the concept of R1 cross F1 at R2 cross F2. That's the concept I'm using. So what is F1? So you put your 20 here, minus 40 here, and then 50. That's from this side. And then here you put your 100 minus 100, 10, and then 50. Evaluate this, and add them. Okay, I will not do that one for. I believe everybody can do that now. Let me do that method 2. You can only use the method 2 for this question because they have the same common R. So any two forces that or more forces that have the same R, then you can use the principle of what I call the principle of moment. So method 2. Because they have the same R, then your resultant moment, let me cut that one short, about O, is just equal to, it's going to be your R, common R, cross your resultant force. That's all. So you have to find your resultant force. Your resultant force is your F1 add F2. So you just add the 2. You just add the 2. And this is equal to your 20 minus 40. Of course, let me add the IJ plus 50. Okay. Add whatever your F2 is, which is minus 100. I plus 10 J. Let me go a bit. Add 50K. And then you collect your terms here. This and this is it minus 80I? This and this is minus 30J. And this is 50-50. If that is the case, 100. Okay. And this is in newtons or pound? Pounds. Therefore, your moment, resultant moment about O is equal to your IJK and your R. The R, we've done it already. Your R, I think we got 4,453. So you put your 4 here, 5, and then 3. And then you put your resultant here, which is minus 80, minus 30, and then 100, and you are done. So what I'm saying is that if you evaluate this answer, which is going to be pound.feet, you get the same answer. Of course, in your IJK, you get the same answer if you do the 2 determinants. If you do these 2 determinants. So zoom a bit out so that you can see. Let me zoom the thing out so I can see. So the answer you get here will be the same. This is also pound.feet, IJ. So if they have the same, so even if it's so many forces, all of them share the same R, or it could be another force here, F3. In that case, you can do this together, and then this will be a different determinant. Okay, and that will be a different determinant. Okay, so this is where I will end this video, and that will enable you to do the next homework. Okay, and that's a vector. All these momenta by point, with that moment of a point 2D and the moment of a point 3D. Okay, thank you. Bye-bye.